let's now do this calculation of R in base and R in total. So, in my AC equivalent diagram, R in base is right here. Okay? And you, in your notes 14 on page 3, notes 14, page 3, where we've got this diagram. Can you show R in base like this? And then can you show R in total like this? Okay. So, in an amplifier, this is R in total. Okay, which is what the signal, AC signal feels the amplifier resistance impedance to be. So, let's first calculate R in base. R in base is, go to the bottom of page 2, notes 14. R in base. What's R in base? Go to page 2 of notes 14. Is it beta times HFE times R prime E plus R in parallel with RL? So you're standing here, you've got your HFE for your gain, and then that is multiplied by R prime E in parallel with a combination of RE in parallel with RL. HFE is HFE total in my case because it's a Darlington pair. So what do? I multiply 175 by 185 multiplied by R prime E 0.37 plus RE in parallel with RL 7.4. Are you with me? What do we get? Oh no, that's, yeah, that's right. This is 7.4. 100 in parallel with 8 is 7.4. What does that work out to? Sure, give it to me in kiloohms, give it to me in megaohms. How many kiloohms? 251 K. Okay, so when we're standing here, that's what the resistance is felt by the input signal coming in. Okay? HFE times R prime E plus RE parallel with RL. R in total takes into account the R1, R2 as well, because that's what the signal really sees at the front end of the amplifier. So that's R1 in parallel with R2 in parallel with R in base. Okay? That's shown also on page 2 of notes 14. So let's do this calculation. R1 is how much? 10K. R2 is how much? 22K. R in base is how much? 251K. So now we've got 3 resistances in parallel. So you can do the 1 over calculation. 6.7K Okay, so that's what my signal feels this amplifier to be, a resistance of about 6.7K. Okay, so in our lab this week, when I build a common emitter as stage 1, then I build a common collector as stage 2, and then I connect a speaker. Okay? This common emitter is connected with a common collector. So this guy is the load to CE. CC is the load to CE. Okay? So in my equation for the gain of CE, wherever there is an RL, I use the R in total. So this is R in total of stage 2, right here. So in my calculation for CE, whenever I do an RL, I substitute the RL with R in total. And we're going to do all of this on Thursday on Friday in our class. So don't skip Friday's class, okay? It's important. Okay, so that's that. Now, we have a couple of more calculations to go, and that is for current gain and power gain. Current gain and power gain. This is voltage gain. Voltage gain is really not a gain. In fact, it's a loss. It's at 0.95. What about current gain in this kind of a circuit? Let's calculate current gain. Current gain is indicated as AI for amplification, I for current. So that's I out over I in. Okay? Just like voltage gain is V out over V in, current gain is I out over I in. So, go to page 3 of notes 14. Go to page 3 of notes 14. Current gain. IE over I in, where IE is equivalent to I out, and that is given to be